we'll continue with talking about the internet layer protocols. All right, so what do I mean by internet layer protocols? Again, I want you to always come back to this diagram, right? This was the network interface, and we talked a great deal about this last week, which was the Ethernet. Now we're going to talk about internet. And what's the word? What's the other, or what does internet stand for again? Internetwork. So how do I get information across different networks? Okay, from one network to another, inter-network. So there are four main protocols that we want to cover today. And in fact, I would say three that I really want to talk about. One is the Internet Protocol. The other one is the Internet Control Message Protocol, or ICMP. The other one is the Address Resolution Protocol. And then finally, we're going to have the Reverse Address Resolution Protocol. I'm not going to spend a ton of time on the last one, but the first three are quite critical. And as I said, if you haven't run into these already, it's going to be something that you run into along your journey very soon. All right, so what is the Internet Protocol? The Internet Protocol is really the main protocol used to send information from one device on one network to the other device on another network. All right, so how does it do that? Well, there's a couple of things that are involved with the Internet Protocol. So the first thing is to be able to create a packet, right? So you remember we talked about the header of the packet containing the source IP and the destination IP. So it's got some of that information on it, in it. It's got, you remember we talked about checksums, right? So checksum just allows you to verify when you get the packet that the information that's within that packet is the same as it was when it was sent across. It's a simple mathematical computation that just allows the receiver to validate the data. So it has to be able to identify the source and destination. Let's just continue. All right, so if I want to send information, again, I need to say, here's the source IP and here's the destination IP, which is fine and dandy. So I'm going to, let's say my computer here, I have a laptop, and it wants to send information to somebody on Zoom. How do I know, how does that packet get from my computer to your computer? Well, my computer knows the IP address of the computer it needs to send the data to because there's that channel already open. But the question is, how does it get there? So the next aspect of the IP protocol is choosing the best path. Now this falls, and we're not going to go into detail into what routing is, but essentially this is done by what is called routing, okay? And every device, every device at this network or internet layer is going to have some kind of a route table. So let's say, for example, so on my local network, and probably on your local networks as well, if you're at home, you all have a router, and your router has a route table on it. All right, so what I was saying is we talked about the Internet Protocol as one of the protocols at the internet layer, and it does, and it's responsible for sending information from one IP on one network to another IP on a different network. It does this by using route tables, and each route table exists in a different hop or in a different router, and that router is only concerned with the next hop. And it does, by using just the next hop, it's able to find the optimal path. So this is the main protocol, creating these headers, source, destination IP, going to the next hop, and the next one, and so on and so forth. But there are a few other things, a few other protocols at the internet layer that are important and useful. So how many of you have heard of the term ping? And we've kind of adopted it. So if I go back to, let's do this. I think I did this with you guys in another class, but ping google.com. Okay, this is using the ICMP protocol, and all it is a management protocol or protocol that you can use for debugging, and it's telling me that the server at google.com with this IP address, remember this is doing a DNS lookup, it uses a DNS server to convert this name into this IP, it's just replying back with some information and telling me it's alive. So that's what this ICMP protocol is used for. It's used for ping. So ping just basically says, okay, ping me, say hello, are you there? But I can also use it for trace route. So if I do trace, let's do Yahoo this time. Okay, what it's doing is it's tracing the hops. Remember I talked about hops? So it's tracing all of the hops to this site, okay, or to this IP address. And you can see in this state, it's probably cached here somewhere, but it's going just from my router to somewhere probably inside FiOS where it's cached, and it's just going 2 hops and I'm getting my answer. Okay, but that command trace route or trace RT in Windows, in Linux it's the full word trace route, it's using this ICM protocol, and all it's doing is it's sending this IP packet across, and rather than forwarding it on, or rather than doing what the IP protocol was doing, this ICM protocol essentially returns the information back saying, I'm here, essentially, right? So instead of the other data packet or header, it uses, or message, it uses this kind of a message. And this computer now knows that this computer is available. So ICMP is a protocol at the IP layer, and it's used for management and debugging. That's really all you need to know. And if you haven't used ping now, up until now, you certainly will if you're doing any kind of networking. But we want to be able to convert from an IP address, we want to be able to get the MAC address, because the IP address changes. We might need to know what a particular MAC address is, okay? So I can look at, in fact, if you just type ARP, if you're on Windows, ARP, okay. So you can see it's showing me, this is the gateway, my FiOS gateway, and this is the MAC address. My computer was, what was my IP? I forget now. 178. So yeah, it doesn't show my own, but here are all the different devices on my network. Somebody's at 153, and somebody's at 155 and 165. So when the data link layer needs to send information, it can query or get the physical address based on IP address, or the or vice versa, the IP address based on the physical address to be able to send that information. So that's the other protocol that exists at the IP layer. It's in order to, because sometimes you might put a new device on the network, and you don't know what the MAC address is. So how do you get it? How can you find that out? Well, you use the ARP protocol to go and do that mapping between the two. Okay, so you have the IP protocol, which is used generally to send information, kind of the main protocol. Then you have the ICMP, which is more for management. You have the ARP protocol, which is for address resolution, or to be able to get the MAC address once you know the IP address. And then you have the reverse ARP, and that's essentially if you want to, when you don't know your own IP address. I don't want to spend too much time on this one, but again, if you need to know what your own IP address is, you can ask another machine for that by using the reverse ARP. Okay. But ARP, ICMP are used, ARP is used every day, all the time, but it's you don't necessarily use it. This is used under the covers by the network in order to be able to get that information. ICMP you use explicitly to do management and diagnostics, and then this IP is used under the covers to be able to send information from one IP to the next. Okay, so those are the IP layer protocols. All right, let's go to the transport protocols. So I've talked a lot about TCP and UDP, or I've mentioned them. I shouldn't say I've talked about them a lot, but I've talked about TCP and UDP as the main protocols. And what I'm going to do now is I'm going to dive a little bit deeper into what these protocols are, the differences between them, why you would use one versus the other, because they are very different and they have two different purposes. So at the transport layer, you'll remember that we are sending information using a particular protocol, meaning either TCP or UDP, as well as a port. Okay. All right, so let's start with TCP. So TCP and UDP, like I said, are the main protocols. So TCP is what's called a full duplex connection-oriented, and it's more reliable and an accurate protocol. And you'll remember what we mean by full duplex, right? Full duplex means you can send information at the same time both ways. Obviously, you need the underlying hardware to be able to support that, but this protocol itself supports it. Now, what do we mean by connection-oriented? Okay, what we mean by connection-oriented is that before it starts sending the information over, okay, it's going to establish a connection. And it does that by first sending a message called SYN, S-Y-N, or synchronize, okay? The receiver sends a message back acknowledging it. And then this is called a three-way handshake. And then the sender sends another acknowledgement. That's what ACK stands for, acknowledgement back, saying that I acknowledge your acknowledgement. It's a three-way handshake. By doing this, we establish a connection, or we establish that the other side is listening, right? So imagine you're trying to have a conversation with somebody and you just start talking. You haven't established whether that person is listening to you or to you or not, right? Sometimes, you have a conversation with somebody and you say, hey, were you listening to me? Well, what TCP does is it makes sure that both sides are listening to one another, that they can have this conversation before the conversation takes place, right? Then what it does, once you establish that that connection is, or once you've established that connection, then what the TCP protocol will do, will take the information and break it into segments, as we've talked about, right? So what does a segment look like? Well, it's got the source port and destination port. The other thing it has is a sequence number, okay? Because one of the things that's good about the TCP protocol is that it'll send information across, but it's also telling the other side how to put it back together. Because in the event that it has to resend a segment, or somehow segments are received out of order on the other side, it defines for that other side, for the receiving side, which order these segments are supposed to be reconstructed in. Okay, and then there's an acknowledgement number, a checksum, some other information here, and other information that we don't need to go into now. But the point is it creates the connection first. It then sends a segment. Okay, and then anytime it doesn't receive, once the receiver gets the segment, it sends back an acknowledgement saying, yeah, I received it. That's what this acknowledgement number is for. And if this side doesn't get the acknowledgement, it will retransmit the segment. So what does this mean? It's a reliable connection, right? Because you can, it's almost, when you go to the post office and you say, I want to send this letter and I want a signature on the other side, you're guaranteeing that the letter is going to get there. If it doesn't get there, you'll have to go out and buy the pack, the parcel or whatever you want to send, and you'll send it again. But you're guaranteeing that that parcel is going to get there. It might cost you more, might take more time, but you're guaranteeing it got there, and you have a peace of mind that it got there. Okay, and that's exactly what the TCP protocol is for. That's why we say it's more reliable, it's accurate, it's sending the information, and it's connection oriented. Okay, it's doing all these acknowledgements back and forth. So let's look at UDP. UDP is slightly different. So UDP is, sometimes they call it fire and forget. So in this case, the receiver says, oh, I want some information. And the sender says, okay, and starts sending information. Boom, boom, boom. Okay. It doesn't care about the order of the segments. It's just, or doesn't indicate the order of the segments. It doesn't wait for an acknowledgement. There's no indication to the sender that the receiver is listening. It's just sending information. Boom, boom, boom. Right? So if you look at it, you look at the segment format or the header format, you can see all it has here is the source port, the destination port. It's got a length and a checksum, but if you compare it to the size of this, it's much smaller, right? Which means this is going to be going to go across much faster. It uses less bandwidth, right? So now, why would I ever want to use a protocol like this? I don't know that the receiver is listening to me. It's not acknowledging that it received the messages. A message could get dropped in the middle. A segment could get dropped, which means part of the message gets dropped. Why would I ever want to use a protocol like this? Yes, definitely faster. So give me an example of where I would want a faster protocol, and I don't care if a packet gets reversed or a packet gets dropped. Yeah, that's right, Peter, VoIP. So voice over IP. So if I'm having a phone call, it actually really doesn't matter if a packet gets dropped here or there. You don't really notice it in your ear. If I'm gaming, I want faster performance. If I'm listening to music, if I drop a packet here or there, it doesn't really matter, right? Now, you guys have all heard about lag in gaming, right? Oh, my computer's lagging. So because UDP is not acknowledging it, right? It's just boom, 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 firing packets. If there is some kind of a unreliable connection between the two devices, then a lot of the drop packets is going to result in a lot of lag or pixelation or just a poor performance. But generally, when you're going to use UDP, you're assuming you've got a generally good connection, and you're more concerned about speed. So I want to send less data because I'd rather have my gaming data go faster and send less of it rather than going, are you there? Yes, I'm there. Here's my packet. Here's a big packet. Did you get it? Yes, I did. Oh, I didn't. Here it is. That's going to take a long time. And so UDP is going to be used when you're pretty sure that you've got a decent connection. But what you're really concerned is about speed and throughput. Okay, so that's the difference between TCP and UDP. Right, so here's a kind of a summary of that, where TCP is going to establish the connection, whereas UDP doesn't establish a connection. It's fire and forget. And the TCP segment is a lot bigger than the UDP header, or sorry, the segment header is much bigger than the header for UDP. So it's going to take a lot more time for TCP. But you can imagine if I was using a browser, right? I don't want to lose segments. I don't want segments to come in the wrong order. Otherwise, my web page is going to be upside down, or I'm going to have holes or missing portions of my website. So that's not really a good use case for UDP. It's a better case for TCP. I can take the decrease in performance because what I'm most concerned about is that my web page shows up. That's why I'm going to use TCP. Okay. All right, so if we were to summarize it in a table, this is what it looks like. TCP is connection oriented. It uses the SYN and the SYNAC to establish the connection, where UDP is connectionless. TCP is slower. I wouldn't say it's slow, it's slower. This is faster. This is guaranteed transmission. This is like going to the post office and saying, I want a signature for someone to receive my packet. Here, no idea whether this person's going to get it or not. Think about a mass mail campaign. If I had, if I'm a company and I'm sending out 10,000 flyers or 10,000 postcards to advertise getting new windows, if 1 or 2 or 5 or 10 of those flyers don't get there, I don't really care. I'm just going to put 10,000 in the mail, get the lowest cost, and get as many out as I can. That's all I'm concerned about. So no guarantee with UDP. There's flow control or acknowledgement in TCP, no flow control. TCP is much more reliable, obviously, than UDP. This is kind of the same as connection oriented. We talked about acknowledgement, and then the header size is much bigger with TCP. Okay. And the other thing I want to just point out here, we've been talking about protocols kind of in a vacuum a little bit without real concrete examples. But these are essentially the elements of the protocol, right? So the protocol talks about establishing a connection, sending a SYN, getting a SYNAC, sending an ACK. So that's the first step. And then the protocol talks about what the header is going to look like. And then it talks about getting an acknowledgement back. So when you put all of those things together, that's what a protocol is. Okay. So that's an example of a protocol. And if you look at the documentation for a protocol, it's going to be quite extensive, put you to sleep in less than 5 minutes. But ultimately, it boils down to things like this: communication flows, who starts, who responds, how do you respond, what's appropriate to respond with. I can send a command, and then I can have a list of response commands. What should be in my header? What size is each field, and so on. Okay, so that's TCP and UDP. So this is our transport layer. So we've covered our data link layer last week, which was Ethernet. We've covered the IP layer today, which we talked about, the IP protocol, ICMP, ARP. And we just covered the transport protocol, which is either TCP or UDP. And then obviously you have to specify a port. But we've covered those 3 layers up until now. Any questions? All right, good. Let's go on. All right, so we're going to spend a bit of time here between now and break, and we're going to look at details of various application protocols. So here are some of the categories: remote access, file transfer, email, web, right? We're all familiar with the HTTPS protocol. That's how you access websites. So we're going to go through some of these other protocols and talk about them. So before I do that, let me do a small demo here, okay? So how many of you have used FTP before? Oh, okay. So let me just pick up that address again. I forgot what it was. Give me 1 second here. Oh, I think this is it. Yeah. Okay. So essentially, FTP or file transfer protocol is a way for me to transfer files from one server to another. So this is a file, an FTP client. It's an application, just like any other program you're going to have on your computer. This is a program. It's connecting a local site, which is my local computer, to a remote site. That's the whole purpose of networking. So how does it do that? Well, this is an FTP program, so it's using the FTP protocol. Okay, I have a test FTP server. Okay, so there you go. A minute ago, there was nothing on this remote site. I don't know if you noticed that or not, but there was no remote site. I was not connected. But all of a sudden, I'm now connected to a remote site. How is my host, my computer, my laptop connecting to a remote laptop? Well, at the network interface layer, I've got wireless, and I've got I've got the wireless protocol, which I'm using, right? The data link layer. Then I've got on top of that the internet layer, and then I've got the transport layer. So at the internet layer, I've put in the host name, which you remember we talked about. This application or will go out and it'll do a DNS lookup on a DNS server, come back with the IP address, because computers don't talk by names, they talk by IP addresses. It gets the IP address. So now the IP layer on my computer knows the source IP, which is my own IP, and it knows the destination IP. It got it by doing a DNS lookup here. So it's sending information from hop to hop using source destination IP. And then at the transport layer, I'm using FTP. I didn't put it in here, but FTP is using port 20 and 21, and I'll show you that in a second. So that's what it's doing. So it's established that connection all the way up through the transport layer. But now that's like we were talking about before. This is like our lesson. I've now connected to Zoom. You guys are on Zoom. I'm on a headset. You're on a speaker. So the connection is done. But now this is the application. This is the education. This is what the purpose of this connection. All the stuff underneath, this was the purpose. So you can see, in fact, you can see the different steps it's doing. It's saying resolving the address, and then it gets the IP address, then it establishes the connection. And the TLS we'll talk about in a second, but it's related to security. Then it's telling you it's logged in. So here's basically the application layer protocol, application FTP protocol starting from here. Okay, so it's logging in, then it's retrieving the directory listing, then it's calculating the time zone. So it's doing all of these things. Now, if I go into this directory, now look at this, I'm able to actually browse on a remote machine the directory. How does it do that? Because there are commands that are associated with the FTP protocol that says change directory. And I'm going to change directory again. And I'm going to say now I want to move this over to just put in my desktop here. Starting download, file transferred. So if I go to my desktop, here's the image from the remote computer. I mean, it doesn't mean anything to us, but the point is I was able to transfer a file. So how does all of this happen? Well, we've talked about how it happens up until the transport layer, but what about at the application layer? What about here, right? On my presentation again. Okay, so FTP, or file transfer protocol, allows you to transfer files between any two machines, and I just showed you that. Okay, it's using TCP, right, on port 20 and 21. And now you should understand why it's using TCP and not UDP, because for sure, if I'm transferring files, it absolutely matters to me that the bytes come back or the packets come back in the right order, the file is reconstructed in the right order, that no portions of that file are lost. UDP would be completely useless here. Okay, and I'm able to do certain things like look at directories, look at the file contents, copying files. So essentially, I've connected a client and a server, and I'm able to do all of these things. Okay, so what is the protocol itself? I mean, I keep talking about protocols. So I showed you an example of the one of the transport, or the transport protocol with TCP and UDP. So here's something similar, right? So what are the elements of the protocol? It kind of looks like this. And this is not anywhere near what the full protocol looks like, but these are just kind of representations, images and words to represent what the protocol would look like. Well, first thing is the FTP protocol defines that you have to have two channels. There's a data channel and a connection channel. Okay, it doesn't really matter for our purposes what these are for, but I mean, you can gather from the words what they mean. But the point is the protocol itself defines two channels. Okay, it also defines certain data structures. So it says when you send a file, this is what the structure has to look like. When you send a record, this is what the structure should look like. When you send a page of information, this is what the information should look like. So it will define, headers, footer, trailers, checksums, anything else that needs to be part of those data structures. And then it also defines commands and replies. Okay, so some of the commands in FTP are pass the username or send the username, and here's the password, and show me a list of all the folders or all the directories that exist in a remote server, or make a directory. And there are a lot more. Okay, but there are some commands that the FTP protocol defines. And then the FTP protocol also defines replies. So if I send a 200 back, that means everything was okay. If I send a 530 back, means there's nobody logged in. If I send a 225, it means the data connection is open, but there's no transfer in progress. So it defines all of these things. And in order for you to create an FTP server or an FTP client, you have to be able to implement all of this. It also talks about, just like with the TCP, what's the flow of traffic? Okay, so in this case, it's it's sending a message saying I'm going to open a passive connection, which port it's going to be open on, and then it's going to connect on this port, and then an acknowledgement. Okay, so you have to follow these rules in order for you to implement the FTP protocol, both on the client and the server. Now, there are other types of file transfer protocols. Here are some of the popular ones. So there's, first of all, what's called FTPS. And as we're going through this, I just want you to make a mental note of the port numbers. And tell me if you recognize anything about the port numbers as we go through the next 10 minutes and go through all these different protocols. Okay, there's something very, should be something very noticeable about them. But we have FTPS, and it runs using the TCP protocol on port 20 and 21. Remember, it needed two. It needed a data channel and a command channel. So FTP Secure is an extension of the FTP protocol, and it adds support for TLS encryption. I'm going to talk about encryption towards the end of this section, but essentially encryption allows you to make sure that the data between your server and the other server that you're talking to is obfuscated, or it's encrypted, or it's unreadable. If somebody were to, let's say, magically plug a wire in and listen on that port, what they would be seeing is a bunch of junk, and there's no way they could figure out what is being sent across. And that whole process is a whole series of classes in and of itself, but I will quickly go over what TLS encryption is. And so FTPS is using the same port and protocol, but it's using TLS. As opposed to something else, which you shouldn't confuse, SFTP, okay? This is protocol uses TCP. This one runs on port 22, but it uses another protocol called SSH to transfer files, okay? And then there's a third one called TFTP, which is Trivial File Transfer Protocol. You can see here it's using UDP, right? So it doesn't, it's not as reliable as FTP. It's going to be used, yeah, it's a lot of info. And, you know, as I said, a lot of this stuff will repeat itself over time, so take in as much as you can. But just keep it, just to note that UDP here is not going to be as reliable. And so, you know, typically you're going to use this in an environment where, you know, you're kind of familiar with the environment, you know that it's reliable, or that you can do without if there was an error in sending that information. But, you know, FTP and FTPS, nobody should really be using FTP, plain FTP by itself. Either you're going to use FTPS or SFTP. Okay. But the point is that you have a lot of different file transfer protocols. You can see the transport protocol that they use, and then the port and what they're used for. All right. So one class of protocols is file transfer. The other class of protocols is remote access, right? Oftentimes we want to remotely connect to another server. And in fact, during the break, I'll set it up. I should have set it up before. I'll set up a remote server and show you how to do it. But why would I want to remotely connect to another server? Well, because I'm the IT administrator, and that server is in a data center somewhere, and I want to access that server, and I want to run some commands on that server. You know, that's typically why you're accessing servers remotely, and this is very, very common. Windows servers, Linux servers, doesn't matter. But in IT, you want to quite frequently access servers remotely. So one of the most common protocols is called SSH, or it stands for Secure Shell. And Secure Shell creates a secure connection between remote machines. And you can see here a diagram illustrating some of what the protocol defines. So the client is going to initiate a connection by contacting the server. And then to do the encryption, we use what's called a public-private key pair, which we don't have to worry about right now. But it's sending over a public key, which the SSH client, or your machine, gets. And then there's some negotiation, and then the channel is open, and then you can log in and start using that machine. So there's a lot of detail, as you can imagine, embedded here. But the point is that this is what the protocol defines. When we talk about protocols, these are the kinds of things that are involved in a protocol. Nobody's going to expect you to create a protocol or define a protocol or anything like that, just for you to understand that the protocols exist. What do we mean by protocol? It's commands, it's establishing connections, it's replies, acknowledgement, no acknowledgement, things like that. Okay, so typically for Linux, if I'm connecting on a Unix-based system, a Linux system, I'm going to use SSH, which uses TCP port 22. And I can connect this way. After the break, I'll show you a quick demo. Okay. So there are other types of remote access protocols. So the other popular one is called RDP. So RDP also uses TCP. And again, you can understand now, hopefully, why TCP is a better choice than UDP for remote access, because you don't want to send a command that says make directory, and by accident, it interprets it as remove directory because something got corrupted along the way. So you're using TCP. It uses port 3389. Okay. Now, RDP, or Remote Desktop Protocol, is a protocol that was developed by Microsoft and is for Windows systems. So there's an application on all your Windows machines called RDP. If you just do run or sorry, the Windows key and then type RDP, you'll see it'll come up here, Remote Desktop Connection. And this is the interface. Just like I showed you an interface for FTP, this is the interface for RDP, but underneath it's using this protocol, and it allows me to connect from Windows to Windows. Okay, and Macs now apparently have RDP client, so you can connect as well. But that's RDP. And then there's something else called Telnet, which is a lot older, and it's using TCP on port 23. The problem with Telnet, you can use it if you want to do a quick and dirty check of your connection to another machine, but the problem is it uses plain text communication, which means there's your usernames, your passwords, everything is sent over plain text. Anybody can just tap into it and see what you're saying. Okay. So we talked about SSH, and then I mentioned RDP, and then Telnet is something that's older, but not something that you should really be using, except for a quick and dirty test. All right, the big, the main protocol here that you guys should all be familiar with is HTTP, and then HTTPS, just like FTPS, just stands for secure. So it makes the connection secure between client and server. It encrypts it so that nobody can listen or read what's on the line. Okay, so HTTP, or Hypertext Transfer Protocol, so HTTP and HTTPS, is used to communicate between web browsers or clients with web servers. And you can see again here some of the elements of the protocol that we've been talking about, right? So in this case, you're going to make an HTTP request, and then there's going to be a response from the web servers. And the request is going to have the version type, the URL, the HTTP method, any headers, and then some elements of the body. Okay, and it doesn't really matter what the details of all of these are, just to keep in mind that they exist and they're defined. That's what makes the protocol. And so some of the methods, so these methods here are get, if you want to get information, post, if you want to put information, store information, and then there's a lot of others, but those are a couple of the kind of key ones. And then some of the response codes, which you should sometimes see. There's a 200. Anytime that you have a successful request, you get a 200 code. And when the page is not found that you're looking for, you get a 404, which you've seen, I'm sure, many times. Okay, and the difference between HTTP and HTTPS is that HTTP uses TCP on port 80, whereas HTTPS is using TCP on port 443. Okay, and I'm going to talk about TLS shortly, but it's essentially encrypting your connection. Then we have email protocols. So a few different email protocols. There's POP, which stands for Post Office Protocol. And it's using TCP on port 110. And by the way, sometimes you can configure these ports to be different if you want them to. These are the default ports or the specified ports. But the newer email protocol is actually IMAP, which is Internet Message Access Protocol. And that gives you a little bit more control over downloading and storing your email and more security. And this is using port 143. So when you're uploading, you'd asked about uploading files by email, that's controlled by whatever email protocol you're using. So if you're using IMAP and you upload it, but there's also email over HTTP, right? If you're using Gmail or Yahoo Mail or Hotmail, that's all email over HTTP. Those are actually web protocols. But there are protocols for when you have a client, like if you're using Outlook or Outlook Express, it uses these protocols to connect to your mail server. And then there are a lot of different other these multimedia protocols, right? So you have SIP, which is kind of a VoIP protocol. And here it's going to use either TCP on 5060 or UDP on 5061. And then this is used for VoIP or multimedia communication. And you can see here you have the option of UDP, because again, if I drop 1 pixel in my image, or if I drop one packet in my conversation, you may not be able to hear that, may not make an impact to you. And so you can use UDP here. Okay. Then you have RTP, which is also for VoIP with options for UDP and TCP. MGCP, which is for multimedia, and H323. Now, I don't think you need to memorize all these different protocols, but the point is that you have a bunch of protocols that you can use, and each is using different transport protocol with a different port. And then there's some other protocols which I've called utility protocols. So if you want to get information about the devices on your network, there's something called SNMP, and that basically goes out and it talks to all the devices and it gets information about the devices on the network. And if you want to manage your network, if you want to get information about your network, you can use SNMP for that. And then another important one, if you guys are on a network at the office at all, your servers, your client, your laptop is typically going to use NTP to keep its time up to date so that your time stays in sync with the with a centralized timekeeper. Okay. All right. Anybody? So I told you to keep an eye on the ports. What do you notice about the ports? Anything in particular? Let me cover. Yeah, mostly using TCP. Let me cover a couple more. Again, keep your eye on the port as well. But DHCP stands for Dynamic Host Configuration Protocol. If you have a network, even at home with a router, your IP automatically gets assigned, because you cannot have 2 IPs on one network that are the same. Otherwise, how do you get information from one server to the other? So every network has to have unique IPs. And so by using DHCP, essentially you have a central protocol that assigns unique IPs to all of the different hosts on that network. And that's what DHCP is for, and that's using UDP on 67 and 68. Okay. And then LDAP, it's using TCP on 389. And this is how, if you've ever connected to a directory on your company laptop or your desktop where you log in and you can log into any computer, but your credentials are centralized in a directory, in a what's called an Active Directory. And so the protocol to communicate with those directories, so to say, hey, here's the user, here's the password they typed in, are they authorized to use this computer? What does their profile look like? All of that uses LDAP, okay, or Lightweight Directory Access Protocol. And then I've talked about encryption quite a bit. So there's the newest encryption protocol is TLS, but oftentimes people still make reference to SSL. So this stands for Transport Layer Security, which is right here, Transport Layer Security. And this one stands for Secure Sockets Layer. But essentially what this does is on top of, or let's say underneath, any of the other protocols that we've been talking about, this establishes a secure connection between two hosts so that any information that goes back and forth between those hosts is encrypted. It will make no sense to anybody if they were to get the raw data. The only way to unencrypt that or to decrypt that data is for one or the other computers that is in a part of that communication link is to decrypt it. And there are special ways that they go about exchanging information and establishing the encryption keys or the encryption mechanism. Again, that's out of the scope of this conversation and this lesson, but those two computers have to establish the encryption keys in order to encrypt the data, and then it's secure. So that's what we mean when we talk about secure connection. We're talking about encrypted connections. Okay, so the one thing you'll notice about all these ports is that, yeah, TCP is more frequent, but you'll notice that these ports are unique, right? There isn't an overlap of these ports. And the reason there isn't an overlap of these ports is that you cannot share ports per se. You remember how we talked about the transport layer defining the port and the protocol. If I have this particular protocol on port 80 and I have another port service on port 80, how would that transport protocol know which service to pass the information to? So what you'll notice is that these default ports are defined by the protocols in such a way that they're independent of one another. Okay, and generally that's going to be the case, that each of these applications or services is going to have a unique port. Okay, that's defined by that particular protocol or that particular specification.